Hey everybody, it's Dustin Mahaffey, and today we're going to work on a MacBook. So first things first is I'm sorry I haven't made a video in a while. I've been really busy. Thanks to you guys, and I really appreciate that, so keep them coming. I've been planning on making the video for about a week. Really wanted to do a PP bus short video on how to properly diagnose that. I haven't gotten one of those in a time frame that I could work with and make a video. So I've pushed that back, and I'm going to work on another device here that an end user actually sent to me. He found me through my YouTube videos, and he said he learned a lot. He actually was pretty descriptive in talking to him about what was wrong with his MacBook. So I figured that I would go ahead and make a video to show him the process and how I fixed his MacBook. So essentially on this one, I believe it was, from what he described, a 5-volt draw. And he actually shipped me the board out of the housing, kind of wrapped in bubble wrap, which is okay. But if you'll notice with this is the board here, it actually kind of bent slightly in shipping. I'm not sure if you can see that well with the camera, but the bend is kind of right in here. It's really hard to tell on the camera, but it's right on this area where underneath the fan. Now there's no BGA chips there in that area on either side of the board for there to be a lot of cracking underneath the BGA chip. There are some, is that a BGA chip? Can't tell. That is. So we may have issues there with it after we fix our initial issue of 5-volt draw. But we'll go ahead and diagnose that as we go along. So the first step here is to plug it up with our amp meter and see what we get. So we'll go ahead and do that now. And I'm sorry, it's been like 6 months since I made a video. One other thing I wanted to say, it's been like 6 months since I made a video, so I'm not as smooth with the OBS controls and all that stuff, so we may have a little bit of glitching in that area, so I apologize about that beforehand. So kind of work with me as I go. All right, so let's go ahead and get a USB-C port on here. Pop that on. And actually, I like to screw these in just so I don't have an issue with them popping out. So grab my screwdriver here. I believe I can steal a screw from here. May not be exactly right, but it should get the job done. Steal these two. Oh, I don't want to screw this in right now because I want to check all the ports first. All right, so, and next we will get our charger with our handy dandy amp meter. The amp meter, I don't like that one. I don't want that one. Where's my good one at? Ah, here we go. All right, and I use this SIG amp meter, and you can see there's cap and tape around it because it's broken many times in the past, and I've had to fix it. This one's actually only broken once. I'm very rough with these things. All right, so we'll go ahead and plug it in and see what we get. Let me see if I can switch you guys over so you can look at the amp meter. All right, guys, so I've kind of rigged up my hand camera so you can see this better. I've literally got it taped to my light, so hopefully that will make it easier for you to see this. All right, so without further ado, let's go ahead and just start checking the current draw on here. And 5 volts, 200 milliamp immediately on that port. All right, let's check another one. 5 volts, 200 milliamp on that one as well. All right, let's move along. We're going to check all of the ports here just to see if we get the same thing on all of them or if we get something different on another one. Let's see. 5 volts, 200 milliamp on that. Okay. It's looking like it's going to be the same for all. Yep, 5 volts, 200 milliamp on that. And that's, again, right away, which is an important distinction, which I'll get into in just a second here. Switch you back over. So the first thing I want to kind of talk to you about is the 5-volt current draw. Not specifically the one we have, just the 5-volt current draw in general. Okay, so on this particular model, you will, in order to get 20 volts, you need several different things, okay? You need the first thing you need all of the CDs to communicate, okay? So there are, to explain that a little bit more, on each MacBook Pro, 2016 and newer, USB-C based MacBook Pro models, there is a chip called the CD3215 or CD3217 on newer models, and essentially there's going to be one CD for every port that your MacBook has. So if you have a 4-port MacBook, meaning you have 4 different ports on it that you can plug it in for power, etc. Then you'll have 4 CD chips on that board, okay? And the all of the amount of CD chips, or all the CD chips that you have on the board, they need to communicate in some way before the computer can negotiate up to 20 volts, okay? So essentially, to kind of to clarify, just because you're getting 20 volts on a 2017 I'm sorry, 2016, 2017 MacBook Pro, that doesn't mean that all your CD3215 chips are okay, because they can still be communicating even though one of them is bad. It's just bad in a different way. Now, that is different. It changes on, let's say, 2018 and newer MacBook Pros because T2 is introduced. On anything with T2, the boot order is different because they added T2. They added an extra chip that needed to be negotiated, that needed to talk to the CD3215 or CD3217 or 15, depending on the model. So that the boot order is different. So for instance, on a 2018 MacBook Pro, if I had 5 volts and 60 milliamps, then I would think, hey, I have a PP bus short, because PP bus G3 hot is one of the first things that you need on a 2018 and newer MacBook Pro in order to start negotiating 20 volts, right? So that would be at 5 volts, 60 milliamps. My first thing would be like, hey, more than likely it has a PB bus G3 hot short, okay? On a, not to get off topic too much, but on this particular model, which does not have T2, then if I had a PP bus G3 hot short, then I would have 20 volts and about 60 milliamps, kind of just the difference in change between 5 and 20 volts, but the same basic draw. And essentially that's because it does not have T2. It does not need T2 to negotiate. So it has a totally different boot up structure, which is kind of going to be what we get into today a little bit on this particular model. Speaking of model, I just realized that I didn't even tell you what device we're actually working on. Right now we're working on an A1707, which is a 15-inch, I believe it's a 2017, could be a 2016. And the board number is, what is this, a 281? Yeah, so 820000281. So again, that's an A1707. Now, the next thing I want to talk about, which is very important, is the normal current draw of a device like this. Again, we are working on a pre-T2 device, but a USB-based device. So essentially that is going to be MacBook Pro 2016 and 2017, and then MacBook, just the MacBook, I think it was 2015, 2016, somewhere around there. Not exactly sure. I don't work on those dead CPU books really. And then you have the MacBook Air 2018 and newer, but that is T2 based, so that's not really going to fall in line with this. So really, this is just going to be kind of for the MacBook Pro 2017, 28, or I can't even talk today, 2016 and 2017. So USB-C based, but prior to T2, this is kind of the boot draw or the boot current that we're looking at. So you'll notice on mine, on each port, I have 5 volts and 220 milliamp draw right away. Immediately, that tells me a couple of things. The first thing it tells me is, hey, the CD3215s are not communicating, because you should get a different type of draw, something like 5 volts, 70 milliamps, 150 milliamps, and then up to 20 volts. So you kind of see that boot up structure. That's one of the reasons, actually, not to get off topic, is I don't like this silver amp meter. I never really recommend it, and that's simply because it's so slow. It doesn't give you that live view like my little black one does. And I'm going to kind of give you an example of that here really quick. So we're going to put our bad board to the side. We know what that's getting on all ports. And what I have here is a freshly fixed board that is an A1708. So the little brother, the 13-inch of this model, also pre-T2. And I'm going to go ahead and plug this in. Oh no, the battery's plugged in, so that will not give us a proper reading. And again, not to get off topic, but to go into that, anytime you're checking current draws, it's very important to disconnect the battery. If you don't disconnect the battery, essentially the reading you're going to get is however fast the battery is charging, or whatever current the battery is charging at. It really is, it's such a variable to throw in there when you're diagnosing the board, so you always want to disconnect the battery. And so I'm going to go ahead and unscrew this MacBook and disconnect the battery, and then we'll see what a working MacBook looks like on the current draw side. Okay, so we'll go ahead. With the battery freshly disconnected, what we'll see is 5 volts, 60 milliamp, and then kind of right away, let me do that again here real quick, try to get this in focus. Okay, we have 5 volts, 60 milliamps, 60, kind of hanging at 60, and then goes right up to 20. So that's kind of what you expect to see. And then let's go ahead and try the silver one. It's kind of a bad example. This model actually boots to 20 pretty quickly, but we'll see. This one takes a minute to boot up, and then it's going to be already at 20 volts, which is kind of, it's too much, you know, it's or not too much, too slow for me. I really like to see that initial boot structure. So we'll see 5 volts, 65 milliamps, 20 volts. I can't even speak as fast as this amp meter is moving. Oh my goodness, this is awful if you can't actually see the draw. So let's try this one more time so you can see the full boot up draw. See how it kind of boots up there real quick. And we should expect to see kind of the very similar, oh, dang camera. I'm sorry guys. But yeah, you'll kind of expect to see a little bit of a drop to about 300 milliamp and then kind of back up to 700 milliamp and kind of idle there during the boot process. That's kind of what you expect. And on this, I'm not sure if you can see the backlight kicking in on it. It doesn't have a solid state and drive installed. So it'll take an additional minute or so to actually boot up to the folder with a question mark here to tell me that it doesn't see the OS. But you kind of get the point from there, and you'll see that that is kind of what we expect to get on a MacBook Pro 2017 or 2016, 2017. Okay, so now that you've seen a good boot draw and then you've seen, or good current draw, and you've seen what we have, you can kind of hopefully see what I'm talking about when I say the CD3215s are not communicating. Now that could be a couple of different reasons why. There could be a short on one of the power rails on the board that are communicated that all of the CD3215s are attached to. That could be causing a similar symptom to what we have now. We could have an absence on an incoming power rail to one of the CD3215s. If we had that or short on one of those lines. Now, however, if I had that or we had that in this scenario where it was a short or no power on an incoming line, then essentially one of the ports would have behaved differently. So like for on my amp meter, for example, on this black Zig, if I have no power on the P-bus 20 volt line, the incoming power line to the CD3215, and actually let me show you that on the schematic here. So let's go ahead and pull up the schematic. All right, so as I was saying, now that we have the schematic and board views up, let's go ahead and pull up one of these CD3215s. And just so you know, on the board, there's one right here on this particular board. There's one right next to it. And then on the other side, there's just one here and then one here. So 4 CD3215s, one per each port, as promised. Now, to kind of, let's look at this incoming line that I was discussing. Let's go ahead and search for this on the schematic and actually go to it. This is it. I know this is a lot. It looks like a lot. It looks complicated. It's not entirely as complicated as it looks, but it's still pretty complicated. So let's kind of dive into what I mean when I say an incoming power rail. So PP20V underscore USB-C underscore TA underscore VBus, that's this line right here. Okay, if I had, just to kind of go into it, looks like it is feeding this CD3215, it's feeding it power. Let's see what that looks like on the board view. It looks like it goes into the CD3215 and through this feedback. No, that's a fuse. That's not what I'm looking for. No, on this model I was looking for, oh, this. This is what I'm looking for, XWB, and you'll see if you click on it, that's just simply a trace inside the board. So if you look at the board where this is, where it says it is anyway, make sure I've got my orientation straight. We'll see, it's right above those test points. Let's get my scope out. Ooh, not knock my camera everywhere. Okay, so if you look on the board view, on the scope anyway, come on, scope, you will see it says that XW should be right around here. There's nothing there. There's a liquid damage indicator right there. There's no physical component on the board. All that is a trace on the inside of the board connecting this line to this line. So essentially it is a wire. Oh my goodness, I was not even on the board view at that time. Let me do that again. Okay, so if we look at this wire on the board view, okay, that's connecting to CD3215, and we go click on the other side of this wire, you'll see it goes right to the port here. So that is telling us, hey, it's getting power from the USB-C port. It is going through this wire, and it is providing the CD3215 with power, and you can kind of see that if we look at it on the schematic as well. You'll see if we follow this line here. Boop, 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 boop. Come on, keep going. Oh, right there it was. So you'll see at the connector, it even says power. It is providing that line. The USB-C port is providing that power. So if I was missing power, this OBS is going to kill me. If I was missing power on that line, essentially my amp meter would just be blank. It wouldn't even turn on, which would kind of tell me, hey, more than likely that CD3215 is bad, or it's short, or that line is short. It could mean a couple of different things. However, in our scenario, we do not have that. We have all of the ports acting the exact same way. So more than likely, what's happening is, again, a communication issue. One of the CDs are not talking to each other. And normally that can happen, the client's using a wrong charger or an aftermarket charger. It can happen from liquid damage, etc., etc. So now we go to, how do we figure out which one of the four are bad? You know, it can't be all of them. It actually can be. That's a bad day, though. It's a long day. But it doesn't have to be. Okay, so let's go ahead and diagnose this and try to start the diagnostic process. Now, you may be asking yourself, hey, where do I go first? If you do not know where to go first, there is a fantastic page that you can go to, Logidoc Wiki, where we give you the tools you need to succeed in order to become a good board level technician. Okay, so I know, just based out of experience, I'm going to check the LDOs for each CD3215. And to explain that for you, each CD3215 is going to produce LDOs. It's going to produce voltage lines that the computer needs to turn on. And each one of them, I think, has 3 or 4 LDOs that all need to be on and working in order for the computer to get 20 volts. But if you don't know that, and you don't know what lines are needed before you get 20 volts, again, let's go to Logi.wiki and we can find it out. So just to pull that up here real quick, go to Safari. I'll just type in Logi. All right, and now we'll go to CD3215 boot up sequence. Yep, right here. And on this page, you'll see a chart that literally gives you step 1 from 17, the the power lines, the data lines that you need, the correct voltage that they should be at, as well as where those power rails or data lines are produced at. So literally a breakdown of the proper boot up sequence for a CD3215. So having this chart, it really makes it easier for you to be able to diagnose these type of issues. Okay, so let's go ahead and just like right at the front of the list, step number 1 is the input line. That's what I was just describing to you guys. At first, of course, it should be at 5 volts because the first thing that the computer does, as you saw on a normal working computer, you should have that 5 volts, okay? And then the step 2 is the LDOs. There's 4 of them, like I was saying, per CD3215. And here it says source U3200. Let's see what that is on the board view. Find U3200. And you'll see that's a CD3215. It's one of the ones I was pointing out. Does this mean if I'm missing an LDO on any of the CD3215s, then U3200 is my issue? No, not at all. That's just one CD3215. If you're missing an LDO for, let's say, go back to the screen. If you're missing an LDO over here, it's not an LDO. Yes, this one. If you're missing this LDO, well, it's generated by UB300, so that is where it's generated. You just kind of have to use a little bit of logic and a little bit of sense and kind of be able to follow that. So if we be able to kind of infer that from that chart. So you can kind of see here for each CD3215 that's listed on the board. This one's the UB300. All the LDOs are listed right here. Here's 1. Here is 2, 3, and 4. Okay, so those are the 4D LDOs. So let's go ahead and start checking those on the board. All right, and we will swap over to the hand cam. I know this video has a lot of me talking and not a lot of me repairing. I'm sorry. I know it's boring and it can be difficult and complicated, but I'm trying to break this down as simple as possible, which requires me talking more than physically doing a repair. So one thing I wanted to point out before I started this is while I'm checking those CD3215s, I'm going to be plugging in, or the LDOs for those CD3215s, I'm going to be plugging in to the port that corresponds with the CD3215. So if I'm trying to check, just to pull you over to the screen, if I'm trying to check this top CD3215 on the top side of the board, you can see the CPU is present, so that's the top side, then I will want to be plugged in to the USB-C port that actually controls the CD3215 or that the CD3215 controls. So how do I check that? Again, I'm just going to, if I want to check this top CD3215, I can just click on that and then swap over to the other side of the XW, which is right here, and I can see that is the top port is controlling this bottom CD3215, or you could simply do that in reverse, so you can select the top or the bottom, which is the PP20 volt line, and then just flip over to the other side of the XW, and you can see which CD3215 is getting power from. So since I'm plugging into the top, you will see that I'll be correcting this, or not correcting, checking this top CD3215. So now, without further ado, we will actually go into starting diagnostic. Switch you over to the scope camera. All right, guys, so I'm going to try to do what I can to keep the scope view out of the schematic view to try to make it easier for you guys to see. But from here, I'm just going to kind of show you how I would do it. So if this is the CD3215 I'm trying to test, I'll just right-click and search it on the schematic. And this is Paul Daniels' Flexboard view that I'm using, which kind of makes that transition pretty seamless and easy. Okay, and then just to show off another feature, here's the 4 LDOs that I'm attempting to test on this particular CD3215. So another great feature is I'm just going to right-click, and it is going to pull me right to that line on the board. And at that point, let me check the voltage here. And I don't have my other camera set up, so you guys are going to just have to trust the voltage reading that I read out. And I've got 3.276, which is pretty close to the 3V3, which is what I'm supposed to have. I'm not going to really raise an eyebrow at that yet. We'll skip to the next PP1V8 LDO, which should have 1.8 volts on it, and that's going to be right below the CD3215. And at that test point, which looks like an easier test point, and I have 1.8, which is good, looking good so far. And we have another 1.8 LDO that we're going to test here, and that looks like there's a test point on the top. Perfect. And it's 1.8 as well, or 1.799, pretty close. And now we have a 1V1. And do we have that? No, we do not. Now with the 1v1, that's weird. If I have, let me just let's kind of skip you over to me real quick here. So with the 1v1 missing, that's pretty weird, as I've seen it many a times where the 1v1 LDO is not there, and that CD3215 that it's missing on is not the actual issue. I have a feeling it has something to do with another CD3215. If it's not producing the LDOs, or if it's not producing exactly as it should and doing everything it should, it can cause the 1v1 to be missing on other CD3215s. So, as a disclaimer, when I see that LDO not being present, I do not automatically look at that as that's the issue. I kind of put it aside, keep it in the back of my head, say, hey, that LDO is missing. But I'm not going to go and swap that CD3215 yet. I'm going to continue and kind of check the other CD3215s on the board and see if everything else is okay. If not, then I'll kind of come back to that 1v1 LDO. All right, so kind of let's continue. We've checked that CD3215 on the top side of the board. That was okay. Let's go ahead and check the back side of the board on the same side, just the kind of the back side. So which is going to be the bottom port. So let's go ahead and do that now. Okay, so moving along to the second LDO here. All right, there we go. All right, this is the back one. So again, we're going to be plugged in. Just to do this backwards this time, we're going to check it. We have it plugged into the bottom port. Okay, fantastic. Now let's go ahead onto this side. Follow that XW back, and it is the right CD3215. Okay, so we're doing good on that. Now we're going to go ahead and right-click, search the schematic for it, pull up the schematic, and kind of jump till we get to the CD3215, and we're here. And again, it looks a little different, but it's all in the same place, and we have our 3v3. Let's see what that is. Zoom in a little bit here. Boop, there we go. And I think what are these two resistors? Yeah, perfect. Right here. And we have 3v3, perfect. All right, and we will switch the 1v8. See what we got there. That's there. But actually looking at the board, look, this component is just knocked off. Right here. Pad ripped off too. Interesting. Let's see what that is. We just scroll up a little bit here. This is PP bus G3 hot. Yeah, that's not going to be our issue. We're not at 20 volts yet. This unit will get to 20 volts. Plus, it's also a capacitor. PP bus has plenty of those. It's not missing that for functionality. So we'll move along. Interesting though. This, like I mentioned in the beginning, this is an end user client. Is not a technician, but he was actually doing very good on his description of what was wrong. Actually, it's better than some of the shops that I work with. I'm not sure if I checked this 1V8 line, but I'm going to check it again. And I do have 1V8 there. And we're going to check this other 1V8 line. See if it is there. And it is perfect. And we'll go to the, again, 1V1 and see what that is. And am I checking the wrong resistor? No, I'm not. It is not present either. So again, see, second CD3215 with the 1V1 missing. So I'm not entirely worried about that yet. Let's go ahead and move along to the third CD3215 that we're going to be testing. All right, moving along to the third port. Same thing. Oh, let me make sure I'm plugged into the right one. Crap. Zoom out a little bit here. If I'm plugged into this one here. And all right, yeah, so this one's the one we're diagnosing currently. And we will go there, check these LDOs, same type of thing. Oops. And where's that at? Right here. Oops. Come on, multimeter cables getting hung up in all the other cables. All right, so let's see up top. Bam, 3v3. And as I'm doing this, I was thinking the first one that we checked actually was low on the 1v8 line. Wasn't terribly low. It wasn't like not there. It was just like I think half a volt low, somewhere around there. And oh, that was one. These are, unless I say otherwise at this point, I assume it's a good measurement while I'm talking out loud. But I'm thinking that it was low enough that I should be worried 3 CD3215s in and not having, and everything seemed to be checking out. So I think what I'm going to do is if all these check out, I'm going to just try to replace that one. And this 1v1 is missing as the other three were. So once more, we're going to check this one next. We're going to switch our port or our charger to the other port. We're going to check this, all four LDOs, assuming the 1v1 is going to be missing for this too. That's this one here. It's a good measurement. So yeah, I'm thinking at this point, the one that had just slightly lower measurements is going to be our issue. That's the first one we tested. And that's 1v8. That's good. That's what I just checked. And that's going to be this third one here. Beautiful. 1v8 as well. And the 1v1, which we will assume is going to be missing, but we're going to check it just because we're like to be thorough. Oh, that'd be weird. This one had the voltage and the others didn't. Yeah, not there either. So now that we have checked all 4 of our CD3215s, all are an absolute spec except for the first one, which again had just slightly lower measurements. Let's go ahead and check that again and see exactly what we get. So I believe it was, I'll flip this board view over. This one. Yes, this is the right board, so we'll just plug it into the top port there. And again, we will check. So right click, search for the schematic. Next, there we are, 3v3. And now I'm going to read the exact measurements, as all the previous were at 3v3 or higher. This is at 3.276, so that's low. This is at hold on, it's supposed to be 1.8. This is at 1.813, which is good. That's kind of what the other ones were at. This one, V8 here, is at 1.789, so low, not by much, but low. And the 1V1 is probably not present, and it is not. Okay, so my first step at this point, or well, I don't know what step number I'm into, but my next step at this point is just going to be to swap that CD3215 that has the lower measurements. Again, not terribly low, not low by much, but low enough to have me raise my eyebrow when everything else is in spec. And again, as you can see, 1v1 is missing on all of them. So if maybe you were a little less experienced, you don't know as much, and you were just reading that list, you would think, okay, all of my CD3215s are bad. And if you have bad luck like I do, that the first CD3215 would have probably been the last one you went to go diagnose. So we're going to go ahead and try to replace that one first and see if that's causing our issue. All right. Short rant here. As you'll notice on this board, what we're about to perform surgery on, or the CD3215 we're about to remove, is right next to a plastic connector. Now, over time, you'll get experience, you'll get the hang of how to heat up and use airflow, air control, air temperature on your station where you're comfortable enough to not use some type of shielding. Now, I'm kind of going on this rant to talk about Kapton tape versus aluminum tape. This is the Kapton tape. I do use it in some situations. It has a lot of great uses. I always have it. But when it comes to like heat shielding, that's not really my go-to. My go-to is aluminum tape, or like air conditioner tape. It comes in a big roll like this, and I just kind of tear off little pieces as I need it. If it's like right next to a plastic connector, you'll see the roll still brand new. I've had it for almost 2 years now. It's something that rarely comes into play. I'm going to use it today just to show you how I kind of use it and how it applies. But it's something that, again, once you get more experience, once you get more confident with your airflow, your hot air gun all together, it's something you'll use less and less, okay? So it's something definitely to have on hand as a beginner. All right, so let's go ahead and flip you over to the scope, and now you can kind of see how close the CD3215 is to this plastic connector. Trying to make that in focus for you guys. All right, so it's pretty close. Give you an idea, or some type of, this is a quarter, so pretty close. Essentially, again, this isn't something you'll melt once you get more experience. The type of configuration I've dealt with many times, and used to use the aluminum tape all the time, but never anymore. But just for the kind of show you guys, you'll see I kind of completely cover the connector in it, and just like that. I try not to press everywhere on it if I have a bigger piece, just because it leaves a residue that I'm going to have to clean in the future. And also keep in mind, this will raise the temperature of that it takes for the chip to remove off the board, because it's a heat sink. It's going to soak up the heat from your heat gun. So if you never use this and you're used to your chips removing at a certain timing and a certain temperature, you have to adjust if you're using a C-tape, because it is a heat sink. It will take longer. All right, so I'm going to turn on my hot air gun. And for my quick, I use honestly about 400,
420, 415, just because the heating element's going bad. It doesn't, it takes a lot more than it used to, this bad boy. It's been with me for about a year now, or 2 years now. It's almost time for a new heating element. So, which is interesting, not the heat quick, but this, you see this is a no stuff connector. I don't think, and this board has all of them, all of the no stuff connectors are on there. I have not seen that before, I don't think. I've never seen a board with these connectors actually on them. That's interesting. I don't know if this is like maybe one of the first boards they made or what. This is also no stuff connector, doesn't connect to anything in the housing, so this could burn away and melt. But you'll see, with the heat flow, this will not melt. This will stay exactly the same. It might look a little different because this heating element is going bad. It's not as accurate as it used to be. It's kind of all over the place. I've been delaying getting a new heat gun because I really want the JVC. I just been delaying it because it's a lot of money that I don't want to spend. All right, so you kind of see I'm not focusing up on the CD3215 right away. I'm kind of heating up the entire area of the board. Don't want to shock the board with too much heat at one time. That's kind of warm enough. So now I'm going to come in. I'm going to kind of concentrate the heat right here on the CD. I'm just touching it ever so lightly, kind of waiting for it to loosen up a little bit. Bam, loosened right there. You'll see perfect lift. You'll see that connector. Not burned at all, yet it's closer than the other one. And that's what I mean. Once you get confident with your heat and your airflow, you won't burn connectors and stuff like that. It just takes time. All right, so now we're going to go ahead and turn on our soldering iron. We're going to add a little bit of flux here. We don't want to drown the board in flux because I don't want to have to give it a bath. Now what I'm doing is I'm mixing the solder that's on the board with leaded solder, which is a little bit lower temperature melting point than the solder that's on the board. And I'm doing this simply because I'm going to wick the pads, and I don't want to wick the pads with the solder that's on there because it's a higher melting point. It's not as easy to mess with and all of that, and it's just it makes it easier to tear pads, and we're trying to do as least damage as possible on this board as we're working on it. So we're just going to kind of mix it with leaded solder there, clean our iron. We're going to clean our flux as the next step. I always like to clean my flux in between each step, simply because if you don't, then you're going to have a blob of flux all over the board, and that's just not what we're looking for. Okay, so we're going to clean that up nice and neat. Doesn't have to be perfect because we're going to introduce new flux to the board, so just pretty clean, but doesn't have to be perfect. And again, just a little bit of flux here. We don't have to go Rossmann style and douse the board. And where's my wick? Somewhere on these parts right here. And chop a bit of this off. And I like to wick the pads on MacBooks. I don't do it on iPhones because iPhone pads tear so easily. But MacBook pads are tough, and they do not tear just by looking at them. So we'll go ahead and wick these, especially mixed with the solder. Not lettuce solder. Or lettuce, sorry. I can't even talk today. I'm not sure why I'm trying to make a video. Some more stragglers at the top. That looks about good. Boop. Dang, that looks pretty good there. And again, once more, we'll clean our flux up. Get that nice and clean. This time we're going to introduce some ISO into the picture. All right, that's looking pretty good. Okay, so now our next step is to put a new CD3215 on there. And so I got new ones in here, I'm pretty sure. I just bought some. I have donors if I don't. Yep, got some right here, perfect. I'm gonna pull one of those out. Now, the one thing with the new CD3215s versus the ones that you pull off donors is that the ones you pull off donors, pretty sure they're going to work unless you're unlucky and that's the reason that they're a donor and you didn't diagnose it right the first time. But if it's pull off a donor, you pretty much know it's going to work. Versus if you get a new one, most of the time it works, but sometimes it doesn't. It kind of throws you off. And hopefully if it doesn't work in a different type of way than the other one didn't. So you can be like, well, that's different. and kind of say, hey, that's a CD3215 failure as well. So now what I'm going to do is I'm going to heat the board before I apply flux to it. And the reason that I'm going to do this is just because I want the flux to melt right away when it hits the board, right? Instead of just having a glob like you were kind of seeing when I was doing the iron. So if I do it like this and I kind of heat the board in this area first, the flux will melt as soon as it hits the board, so I don't have to use as much flux. So now you'll see when I apply the flux will pretty much melt right away as I'm applying it to the board. And you'll see I barely have to use any flux at all. And again, I'm not just a cheap bastard. I really just don't like to clean the boards through the ultrasonic if I don't have to. So especially for something minor like this with no other liquid or with no liquid damage at all, really, I don't want to clean the board just because I've been working on it, in a sense, if that makes any sense at all. And I'm going to use 2 tweezers to set this chip, just because normally it likes to stick to my tweezers. So I'm just going to, looks pretty accurate. And again, we're going to use our hot air. And what we're going to do this time is we're going to, so that chip doesn't fly away, we're going to bring our hot air way up. And then we're going to come down with it slowly as we see the bubbles increasing. So zoomed out all the way on my microscope, as far as you guys can see. And you'll just kind of starting way off here, you see the flux varying a little bit on the sides. That's telling me I'm in the right area. My hot air gun is facing in the right direction. I'm doing good things. Slowly moving this in at this point, moving my hot air gun in. Not very fast, very slow. Don't want that chip to fly away, right? Don't want anything to melt. Very slowly coming in. Now I'm at this point, I'm going to hang out for a minute until I see things to start to kind of come to temperature. And I'm going to come in a little bit more. And you see that surface tension kicking in. That's beautiful. That's what we wanted to see. I'm going to knock it over. Beautiful. That's a perfectly seated CD3215. We're going to wait for that to dry before we clean that little bit of flux that's on the board. You can see not much at all. I know, ooh, that the camera really hates that light. Let me see how to turn this down a little bit, clear it up for you guys. All right. Gonna go ahead and, ooh, too soon. We'll wait for that to cool a little bit more. Didn't mean to hurt your board. Let's let you cool a little more before we start to clean you. With ISO anyway. Nah. Again, trying to be as very least invasive as possible. Little flux on the board as possible. Little heat on the board as possible. Again, several people just kind of go in and start replacing chips. I definitely want to diagnose the board and try to figure out what's wrong with it before you just start randomly replacing CD3215s. I got to turn the brightness up, guys. I'm sorry, I can't see anything through the eyes when I have that light down. So you can see that connector looks perfect. That connector looks perfect. So really, and in some instances, you really need that aluminum tape, especially as you're beginning. It definitely helps. With the lack of burning plastic, but as you grow with more experience, you'll need it less and less. So we're just going to kind of clean this up here. There we go. And we'll see if this works.
Alright, so let's go ahead and test this and see if we fixed our unit. Keep our fingers crossed, pray to the MacBook gods. And what do we get? Oh no, the same thing. Jesus. Okay, let's see if Mobile Centrics sent me a bad part. Hopefully that's what it is. Yeah, just a scope. Okay, let's see if we're getting our same voltage readings. If we're getting our same voltage readings, it means more than likely both CD3215s are good, and I replaced the wrong chip for nothing. And if we're getting different voltage readings, it means that I got a bad chip. So check our 1V8 really quick. And our 1V8 is still low. Okay, so that's kind of what I was looking at. These lines are still low, so it's the same issue we were experiencing before we replaced our CD3215. So we're going to put the old one aside just so I know that's a good one. We're not about throwing those chips away if they're good. So now what we want to do is we want to go ahead and look at the schematic or kind of see what's next in this boot structure. Sorry, I'm scrambling trying to get everything kind of back to where it was here. Sorry guys, give me 1 second. Forgetting the hotkeys for everything these days. Come on. Okay, where is OBS at? Okay, so the first thing we're going to do is hop over to logi.wiki and see, kind of go through this. So we have the HV gate 1 and 2. I'm going to skip by those real quick. I'm going to go to PPDC in. I should have that. Let's check that real quick. Go ahead over here. Fine. Oh, let's switch to scope and screen. There we go. All right. So that didn't work out very well. All right, so that should be, we are on the top side of the board right now, right here. On this resistor, right? No, this capacitor up here. And we are at, oh, not plugged in. We're at nothing because I'm not plugged in. 5 volts there, that's good, that's what I'd expect. We're gonna go back to LogiWiki and check, grab this line, copy and paste it right out of here. And again, just going through the power structure that LogiWiki tells me. Now we're kind of getting to the ISL area, nothing to do with the CD3215s. We'll unplug this, swap the board over, plug this back in, and move us over to that circuit. All right, let's see what we have there. And 5 volts there as well, so that should be good. CPM enable. This is going to be the enable line for the 3v3 line. Let's see if we have that. And that should be easily measured right next to this diode here, right here on this line. And we do have the 5 volt line for the 3v3. And then the next should be, yep, the 3v3 itself. Let's see if we have that. Boop. Oh, nope. I really don't like how the hotkeys change when you're using a Mac on this Flexboard view. It goes back to Windows hotkeys, and I'm always struggling to remember. Okay, check it right up next to the CD3215. Looks like this big capacitor here. Ooh, let's see what we have. 1v1. That's very, very low. Okay, so PP, let's see what we actually have. Let's kind of search this on the schematic. So what we have here is 1v1, 1.1 volt on PP 3v3 G3 hot. So that means PP 3v3 should be 3.3 volts. It kind of says it right in the name there. So what we're going to search on the schematics is see where this power rail is generated. We can see it goes into the CD3215s. Each one of them goes into the keyboard connector, goes into the SMC, it looks like, and to the SMC AV ref supply, whatever the hell that is, because I'm not that smart. Kind of skip right to where it's generated. This looks like, yes, okay, this is where it's generated at. You can kind of tell because it's on this side of a circuit, and normally it'll actually say somewhere like 3v3 power supply or PP bus supply or something like that to kind of make it a clear indicator. Until then, or if you don't have that, you just kind of have to use experience and kind of reading a schematic to be able to identify this is where this is being generated at. So if we're looking at this chip or we're looking at this circuit here, you can see this chip is powered by PPVN G3 hot, P3V3 G3 hot. So if we right click on that, we can hop over to the schematic, or board view I mean, and see if we have that line. It's going to be right over here next to this ISL, and it's going to be this capacitor here. Let's see what we have. We have 0.1, oh, not plugged in again. That's why we have 0.125. Okay, plugging it in, and now let's see what we actually have, which is 4.665. It's kind of low. I would expect it to be about 5.1 volts, and the reason I expect it to be there is because it's being right off driven from a 0 ohm resistor, so like a fuse essentially, from PPDCN3G hot or G3 hot charger, which is a 5-volt line. Even though schematic says 8.6, not when the machine's just board only and on the charger. So the schematic is lying to us. So let's go back to this board views and see what we actually get on that line. So we should get 5 volts, and we get close. We get 4.8, 4.9, not the 5V1 that we would expect. And again, so let's see here. Yeah, that is. No, okay, I'm dumb. I'm measuring wrong. It is 5.126 volts, which now has me second guessing this measurement here, which is, okay, yeah, all right, that's, sorry guys, a little quick detour there. So essentially right here, we have 5.12 volts, which is what we expect. Okay, right here, we have 1V1, which is very low. So we have the power coming in. Right here, let's see what we have right here. Maybe something is wrong with this diode. So check our line right here on this diode. Ooh, move over a little bit. And right here we have 4.66, which we really should have a straight 5.115, which is what we have up here. It should just kind of pass the electricity through here, but it has a drop. Now that doesn't necessarily mean this diode is bad. This chip here could still be bad, causing it to kind of bring down the line. That's why we have the 5.1 over here, but not the 5 over here, because this could bring it down, and diode not allowing this line to be brought down, because that's kind of what a diode does. So it could be this chip. It could very well be this diode. Let's see if this chip is even being told to turn on, which we can see from right here on the in pin, or enable to turn on, to enable the power, right? So we can check power right here, going back to our board view, and that's right above this diode here, and we'll see what we have there. We have 5.1 volts, so it is being told to turn on. Okay, so that's good. So now it's being told to turn on. We have low power coming into the chip, okay, and we have low power coming out of here. So my first step is probably going to be to change this chip and see what we get going on here. And if that doesn't work, then I'll skip to the diode and we'll go from there.
Spoiler alert. As I'm editing this video, this is a troll. This is where I take the measurement. I'm not going to tell you when in this little skit, but I take the measurement that later in the video shows me a full short, when here it shows me a not normal, but not really suspect reading either.
Okay, before I just go ahead and start replacing the chip, I do like to just take quick diode measurements around the chip that I have a suspect of and see if I see anything that's short. So I'll go ahead and do that now. And one side's obviously normally ground. This one's nothing. I have red probe. Probing with my red probe, which is not right. Black, red probe on ground, probing with the black. Good reading. Reading. Don't know if it's good because I don't have known good measurements. I'm just getting a reading that's not short on all of these pins. That's ground, that's ground. Probably supposed to be ground. Let's double check. Yep, all those two are supposed to be ground. Good, 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 good. These are ground. No ground. Ground. Let's see what it's supposed to be. Yep, ground. Supposed to be anyway. Good and good. So nothing short there, nothing short around the circuit. So let's go ahead and just move to replace, repeal and replace that chip here. See what my temperature's at. Good to go. Again, kind of heating up the entire area of the board. Real two suspects is this diode or this chip. I'm going to go ahead and replace the chip first, as I suspect that more than the diode. I think that the chip is bringing down the voltage. I don't think the diode is not allowing it to pass through. But I don't know yet. We'll find out in just a minute. Bam, off just like that. We'll put that in the maybe good pile. We don't know for sure. And again, we're going to do the same thing as we did with our CD3215. A little bit of flux, mix it with leaded solder. Just like that. I'm not going to wick this one. I'm just going to leave it sit like that. I'm going to grab a donor board and see if I can get that replaced. And as you can see, I got a donor board that looks like it came from the pits of hell. No wonder why it's a donor. Look at it. Oh man, I don't even know if this thing looks just awful. Jesus. Wow. As you can see, I removed chips without flux, so that's clearly not me. But yeah, this board was destroyed by somebody. Alright, we're going to pray that this chip works, because it does not look good at this point with how dirty it is. Covered in flux, or I don't know what all that. Kind of reacting the way flux does to heat. Yeah, beautiful, clean lift, alright. I'm going to go ahead and use that existing flux that's still kind of fresh and not that much there, so we can kind of work with what we have. Wait for that Hershey Kiss to go away or start to melt. Perfect. Kind of, oop, knocked it a little too hard. Come on, back into position. There we go. And we're going to remove our heat, wait for the fluxes solidify real quick, and then press down and come back with pressure, waiting for that solder ball to fly out like it just did. Beautiful, that's a good seated chip. And now we're going to just pick up that ball real quick of solder. Oop, there we go. And again, clean. And again, I'm not introducing ISO at this point. Just kind of dry rubbing the flux off the board, waiting for it to kind of cool off to the point I can touch it, and then introduce the flux, or not the flux, the ISO. Now, even if this doesn't work, we're going to really just kind of have a close look at that piece that we put on there. Alright, and now we'll just do the hand camera and see what we get. Where is our, here it is. Alright, let's see if we get anything now. Still nothing. Oh my goodness. Why did I make a video on something that's not going to work? Okay, let's see if we have the same voltages. Alright, back to the scope. And again, same kind of thing with the CD3215 that we did. If we have the same voltages as we did before, then more than likely the chip is good. If we have different, then more than likely the chip that we have is bad. Alright, sorry, just feeling warmth on the board. I'm trying to make sure. Is it producing heat, or is it just still warm from heating it a second ago? Probably still warm from heating it a second ago. All right, anyway. That's not the mode I want. You're not supposed to be in beep mode. Let's see, what do I get right here? Still low, and on the outside, or the output, oh, I'm sorry, you guys are blurry. Let's do scope and screen. And let's see if we can figure out what are you, where are you at right here? Let's just take the measurement there. Still low, actually lower, like by 1/10 of a volt. All right, so now it's time to change that diode, as I suspect that that's my next suspect. Awesome. And once again, kind of just quick dab of flux, mixing it with non-leaded or leaded, whatever. I can never keep this thing straight in my head. And once again, we're cleaning. Alright, let's see what we got this time. Alright, so now we are at the testing stage. Can't talk again. Testing stage again, praying to the MacBook gods, and 192, hey, 197, we're getting something different, but steady, not that current draw. So again, same position, pretty much, a little bit lower, maybe a bad part that I put on there. We'll reassess that. I make a video, and of course, the MacBook that I make a video of is gonna be a horrible video. Okay, so I'm not gonna give up. What am I thinking? Let's see here. Switch me back over to me. So essentially what we have is PP3V3G3 hot is low. It's at about around a volt and not the 3.3 volts that it needs, okay? Right now what we have done is we have changed the diode that pretty much goes from PPDC in the 5 volt line to the power source of the chip, which kind of, once we get through that diode, we go from a 5.1 volts to about a 4.9, 4.8, somewhere around there, or I'm sorry, 4.6, which is low, pretty low, lower than what we need, which made me think, hey, either the diode is bad or the power supply for PP3V3 is bad. I leaned more towards the power supply or the chip that actually generates the line, and I replaced that, no luck. I replaced the diode, no luck. Where do we go from here? We have PP3V3 that's low. So what we do is we kind of go back to an iPhone basic. All right, let's diode measurement that line, or take a diode measurement of that line and see if it's at the right reading. Let's see if it's short. It's not fully short because we have voltage there. We have some voltage there, which means it's not going to be fully short. So if anything, it's going to be a partial short. So let's see what we have. Let's go ahead and take a diode measurement of that real quick. Put our thing on here. And again, so what we're going to do is red probe on ground, and I think I can just pick out the resistor without using the scope or anything and see what we get. Oh damn, we get a full short on ground. That's not what we were getting before. That would have been easy to identify. Interesting. So what was the last thing I changed? Was that diode? Now we're getting different results. I'm just going to go ahead and check around this chip. Kind of makes me think something around here is bad. Not short. We're right around here. Okay, not short around here. Wow, okay. That was not short before. We had already checked this line. Let's see where we're getting voltage wise on this line now. So we replaced the chip first, which actually directly connects to that line, right? Somewhere in here. So it definitely does. Let's see. Go back to the schematic. Oh, let me switch over to the screen. And yeah, this line definitely connects to the chip. Oh, through this coil. That's why I couldn't find it on the board view. Right here. So it directly connects to the chip. But we checked this chip first, and we're still getting the same. Now we're getting full short here. Okay, so we're in a worse position than we were. Let's see what line we have. Again, we're still about 200 milliamps. Let's see what we're getting on this 3v3 line right here. Okay, we're still getting about 0.8 volts, so not a full volt. So again, worse position what we are. So we do have a short. So now what we want to do is we want to look at our board view and see exactly what is connected to this line. That could be short. So essentially any CD3215, it looks like all 4 of them are connected. We have the SMC, I believe this is right here. And we have connector, likely not going to be our issue unless we see direct liquid damage on it. We can take a quick look if we would like, just to see if we see any liquid damage on those connectors, which would cause a short. No, it looks spotless. All the CDs we already looked at, those all look spotless. Like I said, I didn't see any liquid on this board at all. So now our next step is to inject voltage and see exactly what's causing our short on this line. However, I want to make sure there's nothing dangerous or nothing unique on this board. When I say unique, I mean can't be replaced, that if we inject voltage, it could damage in a hard way. And I don't see anything. Go ahead and inject voltage. So one thing that I do notice that this line is on is the ISL. The ISL on this model, or on any MacBook, is known to die. So I'm suspicious of that, but we're going to see what gets hot. Let's go ahead and inject some voltage onto this MacBook here. Get my multimeter probes ready on my DC power supply. Ooh. Switch to full scope mode here. Okay. So first I want to see if the ISL is going to get hot at all. And on my DC power supply, I'm set to 3V3 or 3.3 volts and about an amp. And let's see around here, where can I inject this voltage where I can easily see? Okay, so I can inject right here, down here. I'm probably going to inject right down on this resistor right here, just because it's an easy place to kind of inject and get clear results. Come on now, focus up. Okay, and I'm going to use ISO. I like to use ISO because I don't like to waste my freeze spray. And I hate that bitterant that it has added to it. It's nasty. So if I can identify it with ISO, I'll do that. But if not, I'll switch this freeze spray. We're going to inject right here. Ooh. Oh, look at that. It's not what I suspect is the ISL. But look at this cap right here. It's about to burn up. Bam, bam, bam. Oh yeah, that's our fault right there. And it looks like it has failed more over time, because that line was definitely not full short, or practically full short is where it is right now. So our next step, we're going to remove that capacitor and see what we get out of it, and see if we get any adjustment on the system. Alright, and what is that line on? It is going to be 3V3 G3H reg, and if we look at the schematic, that is going to be this line here. Alright, so got our hot air rolling. Let's hope this is the last thing I have to do to this MacBook. I already spent too much time on it. Client's got a bunch of new parts that he didn't need. And again, just kind of waiting for the solder to loosen. Tapping it with my tweezers, just waiting for it to give me a signal that it's almost there. You can kind of see it's almost there already by the solder on the top of the cap. Kind of burnt out. Visual inspection should have fixed this MacBook. Should have visually saw that burnt cap. Alright. So now we should have a diode reading of about something like 300, 3400, I believe is what this line normally reads at. Let's see what we have. And we have 323. So that is a good reading for this line. So either this chip, well, we got to explain right now, this chip either shorted this line, causing an additional issue. I don't think that's what happened. I think that capacitor was my main issue, and I just replaced a bunch of stuff I didn't need. We're going to let this board cool. Again, that is a capacitor, to be more specific on the board view. Let's just switch you over to there. Let's see which capacitor this is specifically. It is this one right here. You'll see we have 1, 2, 3, 4, 5, 6, 7. 7 total on the line, 6 remaining. This board will boot functionally without that capacitor. And let's see what we have. We are going to pray to the MacBook gods once again. We're going to pray to them before we even plug it in this time and hope that makes a difference. Come on, where's my... Okay. Please, MacBook gods, let this MacBook boot so I can have this video out. Although, I'll probably publish it even if I don't fix it. This has been a good video, I think. Alright, 73, that's good. That's what we like to see at first. Come on, there's the jump to 20. Yes, there's the 5. Yes, that's what we like to see. An amp and a half. Perfect, yes. Alright, now we're going to put this board back in the housing and pray that it turns on and sees its NANDs, and hope that this bend in the board that I was explaining at the beginning of this very long video did not affect anything else. Alright, so with the unit powered on, plugged in, I even plugged in the battery because I just saw the good current draw before, so I know it gets somewhat of a good current draw, so I want to see if it charges the battery at the same time because I'm impatient. Apple logo, that's what we like to see. I'm going to see if I can kill this camera real quick so you don't see the username. So essentially what I tried to teach you today, and hopefully I did a good job, is kind of how the CD3215 circuit works. Even though our specific issue was not a CD3215, it was one of those lines that you needed for the CD3215 to work. As I believe I showed in this video, that line PP3V3 G3 hot was not fully short, or mostly fully short as it was initially. I believe I probed around the CD3215 just to check for shorts, make sure there was nothing short there, and that line definitely wasn't short. If I remember correctly, it had a reading of 137, which I thought was low at the time, but at the same time I was like, other things are low too. So granted, I should have probably jumped right on that, but kind of really did want to explore all of the CD3215 options and kind of show you how I would diagnose a CD3215 circuit.
I did also want to mention something that I learned in this video, as well as I hope you learned something. But one of the things I learned is that if all of the 1v1 LDOs that I was mentioning earlier in the video that I didn't quite understand, if all of them are missing on the CD3215s, then maybe look at the PP3V3 G3 hotline. As you saw, all of them except one was low, but not by very much. It was low by very little, and then it ended up being a short on PP3V3 too. Or I'm sorry, I can't. Once again, can't talk throughout this entire video, but what I learned is that there's maybe a short on PP3V3 G3 hot, or a partial short. So I definitely learned something while making this video, and I hope you did too. So you guys have a good day. I hope you learned something.